arcs and angles. I almost said angels. Many arches that we've seen in structures are semicircular, but Chinese builders long ago discovered that arches don't have to be this shape. So I don't even know I'm not going to try. Shown below was completed in 605, so that was about 1400 years ago, and it's the world's first stone arched bridge in the shape of a minor arc. So let me just kind of put into perspective what you're looking at here, what that means. So most bridges had this shape. Wow, that was awful. Where this is a semicircle. So that's 180 degrees. What the Chinese people did 1,400 years ago, if you notice this right here, let me use a different color really quick. This right here, is that 180 degrees? No, that's not an entire semicircle. So what it looks like is if I were to make a whole circle, wow, that's not right. If I were to make a whole circle, there we go. It looks like it's only this part of the circle. Something like that. Most bridges up to this point, when they were made, they were like that. They were actual like semicircles. But somehow they managed to make a bridge where it was just a minor arc. So instead of being 180 degrees, it's something smaller. Now, why is that significant? It just has to do with, I don't know why it's significant. But we're going to be talking about properties of arcs and the angles associated with them. But what's interesting is this little piece right here. Eric Valadez, could you read this part right here? Arches. So they figured this out 800 years before everyone else, which is just crazy. But somehow they figured out with geometry and all of that, how to build this, how to make it not fall and kill people. And they did this about 1,400 years ago. So let's keep going. So the first thing we're going to talk about are inscribed angles. So in this investigation, we're going to compare an inscribed angle with a central angle, both inscribed in the same arc. So what I mean by that, we talked about this yesterday, this angle right here. I'd like you guys to mark this one, draw a little arrow, and put the word central angle. And we defined a central angle yesterday. So yesterday we said that a central angle is an angle whose vertex is the center of the circle. Do you remember that, Jerome? Jerome, you remember that? That the central angle has a vertex that's the center of the circle, right? And that's just straight from what we did yesterday. Let me go ahead and pull that up really quick. An angle whose vertex is the center of the circle, that's a central angle. Now we have another one called an inscribed angle, and each point of the angle is on the circle. So if I go here, I'd like you all to mark this angle right here, draw a little arrow to it, and write the word inscribed. Now, there's something really interesting that happens when you have a central angle and an inscribed angle, and they both cross through the same 2 points on the circle. And there's a special relationship. So what it wants us to do, it wants us to take our protractor, and it wants us to measure the central angle and the ascribed angle. Right now, we're not going to do that, but let me just go ahead and make up some numbers and kind of tell you what this would be. So let's pretend that this central angle is 120 degrees. Let's just pretend it's 120. And then you put your protractor over to the inscribed angle, and you got 60 degrees. How do they compare? What do you notice about those two numbers? Is there anything special about them? Well, they add up to 180. So Let me give you another example. Go ahead and draw a circle, class. And on that circle, put any two dots. Just somewhere on the circle. Any two dots. Put a center. And I'd like you to make this angle here. Let's start with that angle. And then somewhere else on the circle, let's put another dot. And let's connect it here. So I went and got my protractor. I measured those two angles. And what I ended up getting was that this angle was 80 and that this one was 40. So are we seeing any sort of pattern here? Yeah, what's up, Eric? So instead of saying the word outside and inside, let's use these words. Don't say outside, inside. What do you notice? So what Eric just said is that the inscribed angle, so I understand what you mean by the outside, but the inscribed angle is half of the central angle. Does that seem to track? How about over here? This is the inscribed angle. That's the central one. Yeah, that seems absolutely right. Let's try it one more time. So if we drew a circle here, and I put a dot and 2 points, I'm going to make this real tricky for you all. I'm going to go from here to here, and here to here. And I'm making this up off the top of my head. I don't know if this is going to work, but I hope it does. I would like you to put on this one the number 20. And on this one here, I would like you to put x plus 10. So let's just try this out. Let's see if we can logic through this. What does x equal? So, one second, Eric. So let's think through this. Eric had said that the inscribed angle is half of the central angle, right? So we saw a relationship here. We had 60 and we had 120. We know that the central angle is twice as big as the inscribed, so we've got 120 and 60. Over here, we did an example as well. We have 80 and 40. We have that relationship, correct? So, we know, and I'm going to kind of pick on a few of you really quick. If that's 40, that has to be 80. Do you agree with that? Okay. What if this was 50? Don't erase anything. What would that have to be? 100. Okay. What if that was, I don't know, 70? What would this have to be? 140. Okay, so you're seeing that relationship. So we're going to use that same logic when solving this problem here. So if I know that that piece is 20, what does this here have to be? It has to be 40, right? So that means that x plus 10 has to be 40. Class, go ahead and solve that really quick. Oh, okay. Yeah, good. And x is 30. That is an example of some of the problems that we're going to see. They may be a little more difficult than that, but something like that. So let's go ahead and try to complete the conjecture. The measure of an angle inscribed in the circle is half of the measure of the, now we're going to use the word corresponding, meaning that it goes to the same points. So to the corresponding central angle. Very good, kids. Let's flip the page. Oh no, we got 6 pages of this. It's okay, these are fast though. All right, Ava, what does this say here? So, inscribed angles intercepting the same arc. Perfect. So it says here, let's consider 2 inscribed angles that intercept the same arc. At the figure to the right, AQB and APB both intercept AB. So from A to B, class, I would like you guys to kind of fill in that arc. And then I would like you to mark this angle here at APB, draw a little arrow to that arc. So from APB, draw a little arrow to that arc. And then AQB, draw a little arrow to that arc. Class, do you agree that those 2 pieces, those 2 angles are going to the same arc? Yes or no? Yeah, yes, they are. So there's a lot of like protractor stuff that we're going to look at, but basically this is what's going to happen. Sorry, I lost my train of thought. Let's say this arc is 100 degrees. Let's just pretend that it's 100. Something that we're going to learn here is that not only is the inscribed angle half of the central angle, and I'm trying to see if there's a better way. I want to logic this with you all. Don't write what I'm about to do, but I'm going to go to a new page, and I want to show you something really quick. I want you all to just a little thought experiment, okay? And I think we talked about this yesterday. That if this angle right here is 80 degrees, that means that arc is 80 degrees. Okay? So if that angle in the middle is 80, it means the arc is 80. We talked about that yesterday. The other thing that we just learned today, that if this is 80, this inscribed angle is 40. That's the thing we also learned today. Now, putting this together with this, we know that this arc is 80 degrees. So what I'm going to do is I'm going to erase this. And what I want you to pay attention to is the relationship between those 2. Eric, what do you notice? So not only is the inscribed angle half of the central angle, the inscribed angle is actually half of the, and this word right here is the arc. So the inscribed angle is actually half of the arc as well. So where that leads us to in this question here is if this arc happens to be 100 degrees, what is this measure here? It's going to be 50. But how about the other one? It's also going to be 50. And that's the whole point of this part here, is that if you have 2 inscribed angles that end up hitting the same arc, they're going to be congruent to each other. So, like this here, this to this, and then we have this to this. Notice they're both hitting the same exact arc. Now, I don't know what the arc is, but what I do know is that this angle is congruent to that angle, that they're both going to be exactly the same. And that's kind of the point of this. I told you this was going to be fairly quick. So let's kind of skip through this, skip through this, skip through this. So inscribed angles that intercept the same arc are congruent. So let's go ahead and do an example of this on one of the blank pieces. Let me know once you're ready. Ready, bud? Okay, so students, I'd like you to draw a circle right here. Okay, don't flip the page. It's on the same page. Man, that is a really good looking circle. My goodness. So, I'd like you to put a dot right there, a dot right there. Make a little inscribed angle. And then I got this, and I got this. Okay, class. This one's going to be super tricky. It's going to be really tricky. You ready? Okay. Put x plus 15 and then put 2x minus 10. What does x equal? I want to pause it for a second. So, Nicholas, you just said that they're both congruent, right? Okay, so what's the first one? I want you to write it over there, buddy. What's the next one?
2x minus 10.
So then put equals 2x minus 10, right? So what are we going to solve for? There's the O, right? Okay, so what do we do to both sides? What's a good first step? Okay, I heard add 10. Did you hear add 10? Okay, go ahead and do that. Okay, keep going. Keep going. Don't wait for me.
Oh, wait.
Yeah, okay. You got this? You got this?
Wait, where's the eraser?
Okay, and what's negative 10 plus 10? 0. So go back to that eraser real quick. There we go. Okay. Now, what's a good next step, kiddos? Good. Minus x. That's what I heard. I heard minus x from both sides. Yeah. Está bien. But I heard minus x on both sides, minus x on both sides. Both sides. Yep. And so 2x minus x, that's just x, right? On the right, equals. And then this x minus x, that cancels out. Right? And you're left with 25. Class? Oh, that's weird, the way you wrote that. There we go. 25 equals x. Yeah? Yeah, that was good. Killed that problem. I got to send you to the dean's office because he killed that. All right, kids. But those are kind of the problems you're going to see. Do we recognize that those are the same, right? What if I gave you a problem like this? I promise I'm not trying to trick you. Well, actually, I am going to try to trick you. What if I gave you this problem? Don't write this, please. Could you solve that? Maria, what do you think? But could you solve that? ¿Qué piensa? ¿Piensas que lo puede hacer? Do you think you can do that problem? What's the issue with this one? Class, is it hitting the same arc? No. So you don't know anything about those two. So you can't actually do a problem like this. So the way we could have done this problem is if this angle would have been like that, then now you could do the problem. Yeah. Okay. Let's go ahead and move on. Go to the next page, kiddos. Brianna, can you read this, please? What does this mean? What does semicircle mean? Say that one more time. Half a circle. And what does that mean degrees-wise? What is a circle? How many degrees? 360. So half of a circle would be 180. So basically what we have going on here is it's saying the inscribed angles when the arc is a half circle. Any predictions? I'm going to obviously teach you how to do this, but any predictions? Let me get your mind juices going really quick. You ready? Don't draw this out. If this is 60, this is 30. If this is 40, this is 20. Going back to here, what do we know about this arc? What is it? If that's 180, what is that? 90. 90. How about this one here? Also 90. How about this one right there? Also 90. And how do we write 90s? With the little squares, right? That's basically what's happening here. When we have inscribed angles on a semicircle, we get 90s. So, let me try a problem with you really quick. With that in mind, kids, draw a circle. Put a diameter in there. And then put an inscribed angle that goes to the ends of that diameter. Okay, have we drawn that out? Put the number 20 right there. What is this angle? Would we know how to figure that out? Okay, sit on it for a little bit. Don't just yell an answer. You think we could figure that out? Jerome, you've been quiet today. What do you think about this problem? What would you do here? Nothing yet? I'm going to kind of point back up over here. ¿Lo tienes, Sari? Okay, dime. Okay, so Sari said that angle has to be 90. Do you guys see it now? Because we know that's going through the center, so this is 180. So that has to be a 90-degree angle. And now because of that, we know that triangles are 180. So we got 90, we got 20. What's the missing piece, kids? 70. Thank you so much. Now, even taking a step further, can I try to trick you all real quick? What is this arc from here to here? How much is that? How'd you get 40, Eric? You looked at that one right there? Eric, don't say anything. How about this one? Think 140? That's absolutely right. Because you looked at that one right there. That's a really good question. Okay. We're going to do one more example. Make a circle. Put a center, put a line through it. Boom. Boom. This is 40. how much is this arc? That's the question. I'm going to walk around a little bit. So, what do we get? Class, just say it nice and loud. One more time. Wow, you guys are awful. No, I mean like the loudness. Like, oh, there we go. There we go. There we go. Ava, I'm so proud of you. Yeah, Jerome, what's up, dude? Shh. How do I find 100, right? Okay. I know that's 90. Why do I know that's 90? Because this is 180 degrees, so that makes that 90. Looking at this triangle, what is this piece going to be? That has to be 50. Do you see that, Jerome? So going from here to here, 50 is half of that arc. So 50 is half of what number? 100. What's your question, son? Did I break you? Oh, what happened? Oh, okay. Do you want me to? What do you need me to? What do you need from me? Help me walk you through this. Oh, okay. All right. So angles inscribed in a semicircle are 90 degrees. Let's write that down. Okay, almost done, kiddos. We're really, really close to finishing. So now, this next thing, it's called a cyclic quadrilateral. So what this word means, cyclic, means circle. I think, I'm just making that up. I don't know if it actually means that. I'm pretty sure I'm right. Avery. A quadrilateral inscribed in a circle is called a cyclic quadrilateral. Each of its angles are inscribed in the circle, and each of the sides is a chord of the circle. So I want you to notice something really quick, because this is kind of hard for a lot of kids to see, and so I'm really hoping you understand what's about to happen. So from this point to this point, class, can you draw a line, please? Draw a line just really quick. Okay. Just from there to there. So notice that, and you don't have to draw what I'm about to do, but notice that this angle here is connected to this. But this angle here is connected to this. So why did I show that? Okay? Because between the two of those things, it's the entire circle, right? So what is an entire circle? 360, right? Okay. But this is going to be half of that. This is going to be half of this. What's half of 360? 180. So what that means is that these two together are going to be 180, whatever that is. But then the same is going to apply on the other end. That these two together are going to be 180. And class, what's 180 plus 180? 360, which is a whole quadrilateral. So it all works together. So what does that mean? How is this going to work? So I'm going to erase all this. You don't need to erase it if you wrote on your page. But this is a cyclic quadrilateral. So if we measure each of the four inscribed angles and write the measure of each angle, and we look at the various sums of the various angles, what you're going to notice is that the opposite angles of a cyclic quadrilateral are supplementary. And I'll show you an example right now. We're going to write that down for a second. So let's do a circle. Just put 4 points literally anywhere. It doesn't matter where you put them, just anywhere. And go ahead and connect them. 1, 2, 3, 4. I want to see if I can make this tricky. Okay, I'm going to make up a few numbers, and let's see if we can figure this out together. I'm going to put 80 right there. Bless you. I'm going to put 90 right here. And I'm going to put 50 right there. Okay, let's see if we can logic our way through all of this. I don't know if this is going to work, kids. I'm really hoping this works. Ready, Alexis? Okay. Based off of what I have up there, can I find that angle there? You sure? How would you do that, Eric? So it's based off of that, right? So 50 and 180, or sorry, 50 and 80 is 130, and half of that is 65, so we would say that's 65. Okay. Now, would we be able to find this piece? Do you remember we said that these two angles, and that was the whole point of this little conjecture, is they're supplementary. So since that piece is 65, this piece has to be 115 because together they're going to be 180. Oh, it's weird. My ears just popped. Oh, I can like hear Max talk to me real quick. Yeah, I can hear you. That's crazy. All right. Now, how about this angle right here? Would we be able to find that? Yeah? Using the same sort of logic? Tyler, what am I going to add together for this one? Say that number that I'm crossing over. And? What did I add over? 80. So 90 and 80, that's usually 170? Usually. Okay, so that's 170 divided by 2. Class, dime. What is that? 170 and 2. Let's see. I don't think I can do that off the top of my head. I heard Sadi said 85, and she is totally right. So that's 85. Class, can we find the very last angle? How am I going to do that? Yeah, 180 minus 85, which is 95. What do you think, class? Is that okay? Yeah? Okay, very good. Then we got our very last page. And then we're done. Okay, so what I don't like about this textbook is it just throws so much stuff at you in one lesson. And I apologize, but on Monday, we're going to take a break and really sit in all of this and hopefully get a better, clearer understanding of it. But just know I'm not just going to push forward. We're taking a break on Monday. So we're going to talk about this word right here. It's called a secant. So I want to show you all something really quick. Do you see this line? That's just a line, right? Now what is it called? A tangent. Say that one more time. So this is just a line. And actually, let me put the little arrows. So class, would you agree that that's a line? Now, what is it? Tangent. Okay. Now, if I were to put a segment just from here to here, what do we call that? A chord. Yeah, Maria was saying it, but she just don't want to say it out loud. But she was saying it. She beat all of you. Now, if we take a tangent line, and right now it's tangent, but if you take it into the circle, that's kind of like a chord, except it just keeps going in both directions. So if you have a line that goes through the circle, there's a special name for it. And that name is secant. It's just something that, you know, again, it's not one of those things that your life is going to be radically transformed because you finally learned what a secant is. But we have that. Why am I showing that to you? Is for this. So basically, if you have a circle, and I want you guys to do this, draw a circle right here. I would like you to draw a line through that circle. A secant. So do that. So that's a secant. Now we're also gonna draw a second secant through it, parallel to that line. So to the best of your ability. Now what they usually do is they have you get like a ruler or something and put it on your paper. And because we know rulers are parallel, I'm going to do that with my ruler right here. Oh. And we have that. So we have two parallel secants. So the last thing that we're talking about today is that this angle is equal to this angle as long as those lines are parallel. So let's write that down really quick. If these are parallel, then the arcs are congruent. That's all we're trying to get at here. Now, like I said, there's so much information that I've given you today, and on Monday we're gonna pause and we're gonna really like clarify everything. So I'm not expecting you to know everything right now. There's too many lines. I'm sorry. So let me give you an example really quick. If we drew a circle and put two lines through it, and I knew they were parallel, if this was 43, what is x? 43. That's the whole point of this, is that they're both going to be the same. Why do we learn all this? It's all just very special stuff that doesn't really come up very often, I'm going to be totally honest. But they are important properties of circles that we should know. So Monday, we will be talking a little more about it, but let's formalize it. Parallel signs, or lines, intercept congruent arcs on a circle. Okay. So you do have an ED assignment, but if you don't work on it this weekend, that is okay. Because like I said, on Monday, we're going to sit in all this a little bit and try to really clarify what we just went over. Okay? Cool. You guys can pack up.